So number 5, we had x such that -2 is less than 4, less than x, less than 4. So x is in between -2 and 4, but 4 does have the equal, so you do have to have the equal on the 4. Number 6, it says x is in between 6 and 8, so 6 to 8, and there is no equal, so it's parentheses. Circle which of the following are functions. Well, if I do my vertical line, I hit more than one point, and that's not okay. You can't be at two places at once. So A is out. B, there's only one arrow coming off of every single number, so B is a yes. C, we look at the x values, and right here we see two of them match up, and their outputs are different numbers. So that's not good news. Not a function. D, if I draw a vertical line anywhere, I only am going to touch that line once. It's only going to hit at one point every single time. So that is a yes. D's a function. E, right here, has a problem because the input of 1 goes to the output of 0. Oh, it says -0. That's weird. And the input of 1 also goes to 15, so that's not good. Not a function. F, a person's height and their first name. So if a person is 5 inches, then the person's name could be Sam. Well, if the person's 5 inches, oops, I should say feet, 5 feet. Could be Sam. Someone else who's 5 feet could be Mary. Okay, so just because you're 5 feet, there could be more than one output, more than one name going to that 5 feet. So F is out. F is not a function. A student's ID number and their schedule. So your ID number is 3, 4, 5, 6, 7, 8. And their schedule, right? You only match to one schedule for each of your quarters, so there's only one match up here with your 8 classes. So G, I would say yes, is a function. Given the function, find the average rate of change from f of -1 to f of 1. So we're going to, if we plug in a -1 for all of the x spots, keeping in mind that you do have to have this minus and you have to have parentheses -1 to the 4th. So if I type that in, right, or do it in my head, this is what it has to be. Okay, and so your output, if you do that, is going to give you 4. And then if we put in a +1 and do that same thing, the output is going to give us 16. And if you remember to find the rate of change or your slope, because that's the same thing, we're going to do the y, the output minus the output. So 16 minus 4 over 1 minus -1. 16 minus 4 is 12. 1 minus -1. Subtracting a negative is the same as adding, so it's a 2. 12 divided by 2 is 6. So the answer to number 8 is 6. Number 9, what is the rate of change between these numbers? So again, it's the outputs, it's the y numbers subtracted. So 10 take away -3 over 2 take away -4. So on top I got a 13 and on the bottom I got a 6. That does not simplify, so that's your rate of change between those two numbers. On the interval Rx, on which interval does Rx have the greater rate of change. So if we go from negative infinity to negative 2 is right here, and negative infinity, you're looking at that section. This curve is not very steep right there. And if you were to continue this line, that line stays constant. So if you look, the straight line S would be going faster there. It's harder to climb up in that section. 0 to 1 would be here. And again, you're thinking which one is harder to climb up from 0 to 1, and it would be also that straight line, not the curve right in that section. So the straight line is S of x. Straight line S of x would be faster on both of those. If we look at the next one, they give us negative 2 to 0. Here's negative 2 to 0. Again, if you're going to climb up each of these, the harder, steeper one to climb up is the straight line. So again, that's S of x. And last of all, it says 2.5, which would be right here. 2.5 to infinity. So we're looking at that section. And finally, we see that the straight line is a little bit easier to climb up than that curve right here. So that curve is finally the r of x, which is what we wanted to find out. That is answer D. Our interval is 2.5, infinity. The next one says, from negative 1 to 1, which function increases faster? So if we're looking from negative 1 to 1, in that section right here, which one increases faster? Which one is harder to climb up? Again, it would be that straight line for that piece. So that is S of x. Explain Sue's drive in the country. Well, for the first hour of her drive, she's Sue's drive in the country, distance from home. She's going 80 kilometers from home. In the next hour, the second hour, she is not moving. She's stopped. In the third hour, she is going another, so we're going from 80 to 160. Again, that's another 80 kilometers from, well, she's just going an additional 80 kilometers, so she's now 160 kilometers from home. And then, so for the next 2 hours, she is stopped again. And then she drives again. The next hour, she goes 40 kilometers to home. The next hour, she goes 40 kilometers closer to home. And the last hour, she goes another 80 kilometers and she reaches home. So we want to write something out like that. I'm not going to keep writing that out. Oh, you can do that part. The next one, given the function, find the average rate of change from f of 0 to f of 2. So if I find f of 0 and I plug in a 0 to the function, the output gives me a 3. And if I plug in a 2 for the exponent, the output gives me an 11. So I'm going to do the output, y minus y, 11 minus 3, over 2 minus 0. And if you can't see it from there, feel free to write them as ordered pairs. 0, 3, 2, comma, 11, right? So we're doing 11 minus 3 and 2 minus 0. Or you can do it the other way around, 3 minus 11 and 0 minus 2. So here we have 8 over 2, and 8 divided by 2 is 4. So the average rate of change for number 13 is 4. That's our answer. Number 14, we're doing the same thing. We're finding the change, the average rate of change in our numbers given here. So I'm finding, here we got our y numbers, so if I subtract those, I get 2,212.5, and over here I got 2.5. And I want rise over run, so it's going to be 2,212.5 divided by 2.5. And if I do that, I get 885 gallons, because it's the y numbers over the x numbers, so it's gallons on top over gallons per hour. So that was our airplane, gallons used on the airplane, 885 gallons per hour. The graph shows an investor's net gain from a project starting from the beginning. So what does the y-intercept? Here's our y-intercept. What does it mean in the situation above? So if this is an investor, well, then the investor, he put in $1,000 at the beginning. Or if you want to say he was in the hole. $1,000 when he started his project. So net gain from a project starting at the beginning. Smith family vacation, find their average rate of speed. Notice it's distance and time. If I want speed, it's distance over time. So we're going to go through and find the rate of, or find our slope, because the slope is distance over time. So if I go through and find the slope, I would have 70 here, and notice these numbers always go by ones. So I would be dividing by 1 every single time. So really all I need to look at is over here. The change was 70. The change is 60, 70, 80, 60, 80, 70, 70, and 80. So, and then if I divide each by 1, right, because these are all 1, then those numbers stay the same. And then if I want the average, I'm going to add them all up and divide. If I add them up, I should get 640. And there's 9 numbers over there. So if I divide by 9, I end up with 71.1 miles per hour as the average rate of speed. Number 17, find the rate of change between 0 and 4 hours. At 0 hours, we're here. So 0 is at 160. And if I'm at 4 hours, I'm at 0. So that's 4 comma 0. And if I want to find the rate of change, I'm going to find the slope. So 160 minus 0 is 160. Divided by 0 minus 4 is negative 4. 160 divided negative 4 is negative 40.